Welcome to Land of Math. In this video, we're looking at how you can divide scientific notation. We'll do a real short recap or review some key concepts, and then we'll jump right into solving these problems. We'll have a variety of examples to help you out understand how you can divide scientific notation. All that's coming up next. All right, so dividing scientific notation. So a little bit of background on scientific notation before we get going here. So you'll notice both of these examples right here are written in scientific notation. You'll notice in red, this is called a coefficient, and it's always going to be a number that's 1 or greater, and it has to be less than 10. So in other words, we're always going to have one digit to the left of the decimal. We're always going to go times 10, and then we're always going to have an exponent. If it's a positive exponent, it means that the original number in standard form is greater than 1. If it's a negative, it's less than 1. Now, a couple things when we're moving decimals. If we move a decimal to the right, the number is getting bigger, which means the exponent is going to get smaller. So in the first example, we moved the decimal 2 times. You notice the exponent went from 4 to 2. On the next one, we moved the decimal 1 time to the right, and then the exponent went from 10 to the 5th to 10 to the 4th. Just on the opposite, if you move the decimal to the left, the exponent will be greater. So on this one right here, I moved the decimal 1 time to the left, and my exponent went from a 3 to a 4. The next example, I moved it 1 time to the left, so it went from a -4 to a -3. Now remember, -3 is actually greater than or bigger than -4. All right, so let's look at the first of our 6 examples here. So you can see we have 6.4 times 10 to the 4th divided by 2 times 10 to the 2nd. All we're going to do first is divide the coefficient. So we're going to go 6.4 divided by 2, and that's going to give us 3.2. The second step we're going to do is we're going to subtract the exponents. So we have 10, but it was to the 4th minus the 2nd, so 4 minus 2 is going to be 2. We're going to combine these two try to get our scientific notation. So it's going to be 3.2 times 10, and we're going to keep the second power. So when we subtract, this would be our answer to our first example. All right, example number 2. So in this particular problem, we have 2.5 times 10 to the 5th, and we're going to divide that by 5 times 10 to the 2nd. So just like before, we're taking our coefficients, which happen to be 2.5 and 5, and we're going to divide those. Now, you could do your work off on the side like I'm doing right here, and you can just take 2.5 divided by 5, and when we do the work, we end up getting 0.5, or 5/10. So 2.5 divided by 5, we'll just write down 0.5 for that one. So next, we're going to subtract the exponents. And so 5 minus 2 is going to give us 3. So 5 minus 2 is 3. So we're just going to go 10 and then to the third power for our exponent. We can combine these two right here and try to get our scientific notation. We have 0.5 times 10 to the third. But if you remember earlier, we said that the coefficient, the first number, has to be 1 or bigger. So we're going to end up multiplying or moving the decimal in the first one over 1. So it would be 5 times 10 to the 2nd. Here's example number 3. In this particular problem, we have 4.2 times 10 to the 2nd divided by 6 times 10 to the 5th. We're dividing those coefficients again. 4.2 divided by 6 is going to give us 0.7 or 7/10. We then subtract the exponents. So 2 minus 5, that's going to give us a -3. So we have 10 to the -3rd. Let's combine these. We have 0.7 times 10 to the -3rd. Well, if you remember, we can't, again, we have to have a number that's 1 or larger. So the 0.7, we're going to make it a 7, but because we moved it 1 time to the right, our exponent is going to go from a -3 to a -4. So we're looking at 7 times 10 to the -4th. Example number 4. So another problem here, we have 6 times 10 to the 4th divided by 2 times 10 to the -3rd. We'll go 6 divided by 2, which we know is going to equal 3. And then we're going to go 10 to the 4th minus 10 to the -3rd. So we're looking at 4 minus -3. So this one is one of the most common missed. The answer is 10 to the 7th. So you have to remember, if you're taking 4 minus a -3, that's actually like saying 4 plus a +3, which would equal 7. Now we're going to combine these together. We have 3 times 10 to the 7th because the coefficient is greater than 1 but less than 10, we are all done. So it's 3 times 10 to the 7th. Example number 5. In this example here, we have 2.75 times 10 to the negative 4th divided by 5 times 10 to the 2nd. Our first step again is to divide. We're going to go 2.75 divided by 5. When we do that, we're going to end up getting point, and it's going to be 0.55 or 55 hundredths. We're then going to subtract our exponents. We have negative 4 minus 2. And that's going to give us negative 6. So it's 10 to the negative 6th. Remember, a negative 4 minus 2 is just like saying negative 4 plus negative 2. And that would equal negative 6. So we have 0.55 times 10 to the negative 6. But again, that first number, that coefficient, has to be 1 or greater. So we have to move the decimal over 1. That's going to give us 5.5. It's going to be times 10. And now we have negative 7. All right, last example, example number 6. So we got our problem again, 5.6 times 10 to the negative 2nd divided by 8 times 10 to the negative 5th. Divide our coefficients. So divide 5.6 divided by 8. When I do that, I get 0.7. And then we're going to subtract subtract our exponents. Negative 2 minus negative 5 is going to be a positive 3. So again, just remember, negative 2 minus negative 5 is just like negative 2 plus a positive 5. So that would equal 3. So we have 0.7 times 10 to the 3rd. Again, we have to have a number at least 1 over here. So we're going to move the number 1 times to the right. And it's going to become 7 times 10 to the 2nd power. Well, hopefully that was helpful to you. If it was, please give it a thumbs up. We'd love it if you subscribe to the channel. And until next time, we'll see you on the Land of Math.